Hey, so I am showing you all how to do problem number 1 on homework 6. So you have x and y and they have a joint density function fx comma y with b x y 0 less than or equal to x less than or equal to y less than or equal to 1. Because I have very low memory on my phone, I'm just going to go through it real quick. I'm not going to go through any of the integration, just the learning points. So Okay, so basically we need to find b and a. So we take the double integral of bxy dx dy. You can do dy dx, doesn't matter. Just make sure that your bounds are correct. And the learning point here is to how do you figure out the bounds? And the way I figured out the bounds was the inside integral is in regard to x, right? So I'm looking at x, it's from 0 to y. Boom, there I have it. Okay, outside integral is y. You want a whole number in order to find b, because you're going to set this integral equal to 1 in the end, so you set it from 0 to 1. So therefore, after all the integration, I get b equals to 8. Okay, next. The second part is asking us to find, they're asking us to find, hold on, give me 1 second. Okay, so the second part, B, is asking us to find the marginal density functions f of x and f of y. I rewrote it, f of x comma y equals to 8xy, as we found in the last equation. This is always really important, 0 otherwise. So I kind of like cut it down the middle to show you what happens. F of x, to find the marginal density function of x, you take the integral in respect to the opposite variable. No, I don't want to say the opposite variable, the other variable. Same thing with f of y. I did it in regard took the integral from negative infinity to infinity f of x comma y dx, and then over here I have for f of x equal to negative infinity to infinity f of x comma y dy. Here, and so here is the math that I did. Eventually I arrived at f of x equals to 4x minus 4x cubed, and f of y equals to 4y cubed. And these are their graphs. And this one I did by computer because I wasn't so sure, but this one, it should be more curved because the 4 is actually really low. You just plug in 1, you get 4, right? You plug in 1/2, you actually get 1/2. And then you plug in 0, you get 0. You got 3 points, there you go. You can just connect it. All right, next. Quick, how do you find out whether they are independent or not independent? You do f x comma y equals to f of x times f of y. If that is true, then they are independent, but it is not true, as you can see. F of x comma y does not equal to f of x times f of y. Okay, so this one was a little bit, sorry, I had writing in the back, so hopefully you can see it. Okay, so part D, we're trying to find expected value of x, expected value of y, expected value of x and y. So we need to, we use the marginal density functions from the last part, and we use it to find the expected values. Simple enough. The expected value of x is equal to, from 0 to 1, like I said, I rewrote the bounds just to show you. How did I know it was from 0 to 1? X is between 0 and 1, and you're trying to find like a solid number, therefore you want to use both solid values, right? Solid bounds. So I did x times f of x, which is 4x minus 4x cubed dx. This is all my math. Eventually I arrived at expected value of x is 8/15. Expected value of y, we have again from 0 to 1, because you're trying to find a solid number. You're not just trying to find, like, you know, a function. So or a density function. So y times 4y cubed, that 4y cubed is the marginal density function of y, and so it turns into 4y to the 4th. Simple integration, eventually I get 4/5. Expected value of e to the xy. This one requires a double integral, but it's not too bad. This one, the bounds are actually very important because the first one you want the bounds to result in all x's turning into y. So I'm looking at x, my inner integral is dx. I'm going to set the bounds from 0 to y because x is right in between, okay? So as you can see here. And then the outer bounds, since I'm looking for an actual number, I'm going to use a solid number, which is from 0 to 1, okay? So so you got xy to xy, which is essentially 8x squared y squared. Pull out the inner integral 8xy squared, integrate from 0 to y x squared dx, eventually get x cubed over 3 from 0 to y. And then you get from the larger integral, the outside integral from 0 to 1, 8y to the 5th over 3 dy, okay? So pull out the 8/3. Basically, I'm just showing how to integrate, which I said I wasn't going to do, but just following my train of thought. Pull out the 8/3, integrate that, y to 6 over 6 from 0 to 1. You eventually get 4/9, okay? All right, part E. Part E is asking us to prove or disprove that x and y are correlated or are prove or disprove that x and y are uncorrelated. This is the proof to show if this is true, then they are uncorrelated. It is not true, so therefore you can't say that x and y are definitely correlated. The only way you can say it is x and y are not uncorrelated. Okay. Okay. Part F, which I have right here, is to find the conditional density functions f of y given x and f of x given y. Simple enough. F of y given x is f of x comma y over f of x, and f of x given y is f of x comma y over f of y. Sorry it's so ugly, but I basically did the math on here. They're just 8xy divided by 4x minus 4x cubed, and this used to be 4y cubed before I started like canceling everything. Eventually you arrived at 4 f of y given x is equal to 2y over 1 minus x squared, and it's a line. This is line on a fixed x graph, and the slope is 2 over 1 minus x squared. Here we have the f of x given y is 2x over y squared. Again, the graph of this is a line, and the slope is 2 over y squared on a fixed y graph. All right, so that's F. Now we work on G. Okay, G is we're trying to find the expected. Here, let me show you F again, just in case I might have glanced over it real quick. Sorry, there you go. All right. So G. Okay, so G, we're trying to find the expected value of random variable y over x. The expected value of random variable y given random variable x, and the expected value of random variable x given y, and the expected value of x random variable x given random variable y. Okay, so listed it all out here. It's not too bad. You just kind of got to figure it out. The first one, the learning curve, not the learning curve, the learning point in this exercise is this. The expected value of random variable y over x is the integral from the bounds. The bounds are shown right here. Why do I use x to 1 in this one? Because I'm taking the integral in regards to y. So y is between x and 1. So and the formula is, I scratched it out, but this is a y. The formula is integral from x to 1 y f given y of x dy. And we have the conditional density function. We figured it out, like, I think back in part F. So we basically just integrate this formula, and eventually through integration we get 2/3 times quantity of 1 minus x cubed over 1 minus x squared. It's for y over random variable, for random variable y over random variable x, it's the same thing, it's 2/3, but the x's are changed to random variables. Okay, and finally we have the expected value of random variable x over y. Same concept, you're doing the integral from 0 to y, and y is 0 to y because x is between 0 to y, of x f of x given y dx. And that's why the bounds are from 0 to y, because you're doing the integral in regards to x. So multiply that out. We found 2x over y squared in part F. Multiplying it out gives us 2y over 3. And again, with the same concept, the random variable x over random variable y, the expected value of that is you just replace the y with a random variable y. And that is problem number 1 on homework 6. Thank you.